Hi guys, it's Mr. Krieger. This is Unit 8, Part 2, Lesson 8, the directed line segment. This will be the first lesson out of 2 lessons on this topic, on directed line segments. So please make sure you print up your lesson, and let's take a look. All right, so let's say the Hewlett baseball team is playing a game and the score is 5-2. Who's winning? Well, many of you might think that if the game is taking place at Hewlett, Hewlett would have the score 5 and the opponent would be 2. But let's say you don't know where they're playing. Then you wouldn't be sure. We would say we're not sure unless we have more information, right? In other words, which number goes to which team? And again, if you're the home team, usually you get the first number, but if someone just said, oh, the score is 5-2, you would need more information, right? Well, that relationship between those numbers is the kind of relationship we're going to be dealing with when it comes to the directed line segment. If we want to say we want to break a line segment into 2 parts, not the midpoint, not that point, but let's say 2 unequal parts, let's say 2-1, you really need to know where the larger segment is going to be. Is it going to be on the one end or on the other? In this particular case, it looks like it's on the left end. But we're going to need to know the direction so we know where the bigger part goes and where the smaller part goes. So a directed line segment is a line segment that has direction associated with it. That has direction associated with it. Okay? So we want you to notice in this example that the longer part is from E to F. Well, please copy this down. That's the 2 to the 1. The EF compared to the FG. Okay? That's important because maybe if you wanted it to be 1-2, this point would have to be further so that this portion would be smaller and that portion would be larger. But in this case, it's clearly this is the larger portion, this is the smaller portion. So let's take a look at another similar kind of example. Let's turn this example's ratio into a fraction comparing the larger part to the whole. Always make this fraction, part to whole. Divide these marshmallow peeps into a ratio of 3-2. So what we're going to do is we're going to add these 2 numbers together. That's the total number of parts we want to make. And then we're going to want to split it into 3 parts to the left and 2 parts to the right, right? So basically, in this particular example, if you count the number of peeps, there's 10 in total. And you want to do this. You want to do 10 divided by 5, because you want to break the 10 into 5 parts. That means there's 2 peeps per group. In other words, suppose you have 10 peeps and you had 5 friends that you wanted to share it with. How many, if you're sharing it equally, how many peeps does each friend get? 2 peeps per group. But we're not sharing it here. We just want to find the location that splits these peeps into a ratio of 3-2. Now, since each group of 2 makes a group, let's break this into the number of groups we need. So I want you to notice this is one group, this is the second group, this is the third group. Every section of peeps gets broken into a group, right? And this is the dividing line right here because this is going to give you the ratio of 3 groups to the left side compared to 2 groups on the right side. So this is the split that will break our peeps into a ratio of 3-2, okay? So this is using like real objects. We're going to be doing this with line segments. So let's go take a look at a problem. Again, this problem is similar to the PEEPS problem, but now we have a line segment. The coordinates of the endpoint of AB, and I'll label this A, and I'll label this B, are 1, 3 and 11, 3. The points are already marked. We're going to want to find point P, which is on this line segment, that partitions or cuts the segment into a ratio of 2 to 3. Basically, we want to find that location that will break this line segment into two segments, one which is 2 parts compared to the other, which is 3 parts. So, first of all, we should note that A to B is 10 units. You could actually count those boxes. You'll see there are 10 units, right? Now, what are we going to want to do? We want to break it. We're going to take that 2 and 3. We're going to add them together to make 5. So we want to take 10 total units, break it into 5 groups, which means there are 2 boxes for each part, for each group. Okay? So what I'm going to do here is I'm going to, after every 2 boxes, I'm going to make a little mark. And that's going to make 1, 2, 3, 4, 5 groups. In other words, every 2 boxes, which I indicated over here, is going to make a group. That gives us 5 total groups. 1 from point A to that mark. 1, 2, 3, 4, 5. 5 groups. Now the thing is to find how to break this into 2 to 3. All right, so you can follow these directions in order to get this. If the ratio is 2 to 3, then how many portions are there in the line segment? You know, again, you take your 2 plus 3 to make 5. Break the line segment into the number of parts you found here. So we broke it into 5 parts. Should point B be closer to A or to B? So basically, we're going to be putting point P somewhere. Do you think it should be closer to A or to B? Well, P should be closer to A, because when we take a look at the ratio 2 to 3, the 2 part is smaller. So point P should be closer to A. Does that make sense? All right, so now we got to count off. Here's the 1, 2, 3, 4, 5 parts. That's 1 part, 2 parts. This mark right here indicates where point P will be, 2 parts compared to 3 parts. Therefore, point P is the point 5, 3. 5, 3. All right? So that's how this works. Let's try some more examples. Okay, for the next problem, we don't have the line segment drawn, so we're going to have to draw the line segment. So I'm going to do that with a regular pen. So point A is the point 3, 2. You should find that location yourself. 3, 2, that's here, that's point A. Point B is 8, 12. That's right here. I'm going to connect those points A and B. And one thing I'm going to show you is that the graph could be helpful, and some people might like to use the graph. Sometimes a better technique is to not even use the graph. I'll show you what I mean. Make another graph. But first, let's do the first thing, which means take the ratio, the 2 parts, add them together. So that's 3 plus 2 makes 5. So we know we're going to have to break this line segment into 5 parts. But as I was telling you before, sometimes it's better to use not the grid paper, but just to make a line segment, make it long enough so you have room to work. Call this point A and call this point B, okay? Doesn't matter whether it was slanted or not. What we're going to do now is we're going to break it into 5 parts. So I just want to make 5 marks about equally spaced along AB. If I want to make 5 parts, I got to make 4 line ticks. So basically 1, 2, 3, yeah, like maybe 1, 2, 3, 4. That makes from A to this point, that's 1 segment, 2, 3, 4, 5. That's how many parts it had to be broken into. Always use the left point, usually the first point, as your left point on your straight line segment. So 3, 2 is going to be here, and 8, 12 is going to be here. Now the idea is to find the locations of each of these points. In other words, what location would this be? We're going to find that out right now. So here's what you're going to do. You're going to subtract the x values. The x from here minus the x from here. So 8 minus 3 equals 5. Okay? You're going to take this 5, and we know we have to break it into 5 parts. We're dividing by this 5. We're going to take the 5 units from 3 to 8. 8 minus 3 was 5. Break it into 5 parts, which means that we're going to be adding 1 to each x value. Watch what I'm going to do. Starting with the 3, I'll move this over a little bit, hopefully you can see all this. Starting with this 3, we're going to go up by 1s. So 3 plus 1 is 4. That's going to be the x value for this point. 4 plus 1 is 5. 5 plus 1 is 6. 6 plus 1 is 7. And then 7 plus 1 is 8. That gets me to the other endpoint. I'm going to do something similar for the y values. The values here, 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 here. But I'm not going to use 1s. Instead, now what I'm going to do is I'm going to take the difference from b to a of the y values. 12 minus 2 equals 10. I'm going to take that 10 and divide it by this 5, and that's going to give me 2. This is what I want to add to y's. This is what I added to the x's. This is the value I'm going to add to the y's. So starting with this y value of 2, I'm going to add 2 to get 4. I'm going to add 2 to the 4 to get 6. I'm going to add 2 to the 6 to get 8. I'm going to add 2 to the 8 to get 10. And then you could see for yourself that the next time you go up by 2, you get back to 12. We've now gotten the locations for each of these line segments, and we have this line segment in 1, 2, 3, 4, 5 parts. Now we just got to figure out how to break it into the parts 3 to 2. 1, 2, 3. This is the breakdown right here. That's where the point P is going to be. So point P is going to be the point 6, 8. Okay? So you don't even need a slanted line. A horizontal line will work just fine. Let's try another example like this. Okay, in the diagram, AC has endpoints -5, 2 and 4, -10. If point B is on AC such that the AB and BC is 1 to 2, in other words, A to B and B to C is in a ratio of 1 to 2, what are the coordinates of point B? Now, point B is going to be closer to A, but we got to find the exact location. As I was saying, let's not use the slanted line. Let's use a horizontal line. Always the left point goes to the left, and that's going to be the point -5, 2. And this point C is going to be 4, -10. Add 1 and 2 together, so 1 plus 2 equals 3. We need to break this line segment into 3 parts. We need 2 marks. Now, you always do 1 less mark than the number of parts you want. We want 3 parts, you're going to make 2 marks. 1, 2. Why? 2 marks makes 1, 2, 3 sections. So you always do 1 less mark than the number of parts you want, okay? And now we have to find these locations. Just like before, what we're going to do is let's find the difference of the x's starting from the C, the x from the C point. 4 minus -5 is 9. And basically the difference, the distance between -5 and 4, that's 9 units. What do we do with this 9? We divide it by 3. That means we're going up by 3 units for each x. Add 3 to each x. So if you're starting with -5, the next point, -5, add 3. You go to -2. By the way, I'll show you something on the calculator. If you start with -5 and you do +3, that gets you to -2. If we add another 3 on, that gets us to +1. And if we add another 3 on there, it gets us to 4, which is exactly where the point C is going to wind up. That's where we want to be. Let's try the same thing for the y's. Take the -10, starting with the y value from the point on the right, and subtract off 2. That gets you -12. Take -12 and divide it by 3, this number, And that means we're going to be subtracting 4 to each y. All right, let's see how that works. We're starting with this y value of 2, and then we're going to subtract off 4. So now we're at -2. We're going to subtract off another 4. That brings us to -6, this one. And if we subtract off another 4, which isn't really necessary, but just to check, -10, that's exactly what we get here, -10. So let's see what we got. We got the 3 parts. We want to break it into sections of 1 to 2. 1 here, 2 there, which means this location right here is going to be our B value. We're going to call it B in this case. So the point B is the point -2, -2. And that's how you do this. Okay, one more example. And by the way, before we get to the example, this walks you through all the steps I was just talking you through. And you're welcome to look this through in order to understand better. And we'll do one more problem. The interesting thing about this problem is that you wind up having to deal with decimals. But as you'll see, it doesn't matter whether you're dealing with decimals or not. It will work no matter what. So let's graph the points first. Point R is -3, -4. 1, 2, 3, 1, 2, 3, 4. That's point R. Point S is 5, 0. 1, 2, 3, 4, 5. That's point S. Connect those points. We want to find the location on this segment RS that's going to break it into parts of 2 to 3. So basically, we're going to be finding point P. So you should know, first thing to do is to add these two together. 2 plus 3 gives us 5. I'm going to make a line segment here, R and S. R is the point -3, -4. And point S is 5, 0. And we need to break it into 5 parts, which means I need 4 marks here, 1 less than 5. Let's see, I want to make it about equal. So 1, 2, 3. I didn't do such a great job there, but it doesn't really matter. It's going to be a little squished for me. Should have moved this over a little bit. All right, so let's see what we're going to do now. Next step is to take the difference between the x's, 5 minus -3. I'll do this over here. 5 minus -3 is 8. There's 8 units between -3 and 5. I'm going to take 8 and divide it by 5, and that's going to be a weird number. That's 1.6. That's what we're going to be adding to our x values. So how are we going to do this? Starting at -3, we're going to add 1.6, which gets us -1.4. -1.4. Add another 1.6 to that, 0.2. The next one is going to be 0.2. Add another 1.6 to that. That gets us to 1.8. Add another 1.6 to that. That gets us to 3.4. And then if we add another 1.6 to that, you'll see you get to 5, which is exactly where we wanted to be when we get to S. Now, let's do the y's. 0 minus -4 is 4. We're going to take 4 and divide it by that number. That's 0.8, and that's what we're going to add to the y's. So starting with -4, we're going to add a 0.8 to that, which gets us -3.2. That's -3.2 there. I'm going to add another 0.8 to that, -2.4. I'm going to have to put that underneath, -2.4. I'll put the y values underneath. I'm going to add another 0.8 to that, which is going to get us -1.6. I'm going to add another 0.8 to that. It's going to get us to -0.8. And if we add 0.8 to that, it gets us to 0, which is exactly where we want to end up, at 0, right? So, I don't know if you can read these as -1.4, comma -3.2, 0.2 and -2.4, x and y, 1.8 and -1.6, x and y, 3.4 and -0.8. Now, we wanted to break it into a ratio of 2 to 3, which means 2 parts on the left side, right here, and 3 parts on the right side, which means our point P is 0.2, comma -2.4. Okay? So that's how you do this type of problem. Please try the homework out, and we'll do more of these kinds of examples in the next lesson.